My name is Flores Urrutia, and I am a technical officer at the WHO Department of Nutrition and Food Safety. My role is to work with the Global Micronutrients Database, collect global data on the macronutrient status of populations, validate this data, and then integrate it into the database. The data from this database is used to produce country, regional, and global estimates. The Micronutrient Survey Analyzer is an online tool developed by the Department of Nutrition and Food Safety with the aim of allowing the user to perform comprehensive analysis of macronutrient status survey data for all populations. To note that the analyses are based on the WHO guidelines. This first version of the tool provides results for 4 biomarker indicators: hemoglobin, ferritin, urinary iodine concentration, and iron deficiency anemia. On this training, we will be only using the training version for hemoglobin, as we are still validating the results for other biomarkers. This online tool is designed to build country capacity on data analysis and reporting on macronutrient status of populations. It aims to enhance good practices in collecting survey data, analyzing, and reporting results. The Micronutrient Survey Analyzer is a useful tool for individuals in national statistical offices, data collection specialized agencies, or programs, research centers, or any other institution responsible for data analysis of macronutrient status indicators. It can be a helpful aid, especially for those who don't have access to a standard statistical software to analyze surveys. Some of the key features of the Micronutrient Survey Analyzer are standard analysis according to the WHO recommended cutoffs to define macronutrient status of populations, disaggregated by age, sex, pregnancy status, type of residence, and subregions and districts available. It will also provide calculations of confidence intervals and standard errors around the estimates that take into account complex sample designs methodology whenever is the case. For each index, weighted and unweighted sample sizes are provided. These analyses are presented in short and long format. It also provides a data quality assessment taking into consideration input data distributions, adjusted data distributions, percentage of missing and implausible data. In addition to the online graphics and tables that can be easily downloaded, it provides a summary report template that already includes main findings and key outputs for data quality assessment based on existing best practices for reporting. The main outputs of the Macronutrient Survey Analyzer are: the individual classification file provides individual classification of macronutrient status according to WHO recommended cutoffs to define macronutrient status of populations. The short format prevalence file includes prevalence estimates with corresponding standard errors, confidence intervals, and summary statistics, that is, mean and standard deviation. The long format prevalence file includes a wide range of cutoffs, including prevalence estimates with corresponding standard errors, confidence intervals, and summary statistics. The data quality report provides histograms and figures depicting data distribution, missing and implausible values. All results for short and long format are provided at overall and disaggregated levels for all available stratification variables that are age, sex, type of residence, geographical regions, well quintiles, mother education, and one additional factor if the user is interested in and for which data are available in the user's dataset. This tool is based on R code and uses R Shiny package. As such, there are some basic rules that will allow its efficient use. The analysis of surveys containing macronutrient data requires that many of the input variables are defined according to the specific format or code. The user is strongly encouraged to perform the data file preparation prior to importing the data file into the Micronutrient Survey Analyzer. To have the best accuracy in the output estimates, the user should know the compulsory variables and the accepted or recommended values and formats for each of the map variables. This information is available in the tool's quick guide. The Micronutrient Survey Analyzer includes validation checks for each of the variable map as input for the analysis, and provides user-friendly messages to guide the user for detecting potential mismatches. The data file to be imported should be in the comma-delimited format, .csv. This file can be created in any spreadsheet computer application in tabular form such as Microsoft Excel, and once the dataset is properly organized, it can then be saved or transferred to the CSV format. The quick guide will help users to prepare the variables in the dataset in the correct format. Any variable label can only contain characters and numbers. It should not include spaces or symbols. This also applies to the file name to be imported. There are 6 steps for data setup. Step 1. Upload the data file with correct values and format. Step 2. Data preview to check that everything is okay. Step 3. Choose the biomarkers to be analyzed: hemoglobin, ferritin, urinary iodine concentration, or iron deficiency anemia. Step 4. Map standard variables such as age, sex, or pregnancy status. Step 5. Choose biomarker-specific settings for the biomarkers that we have chosen in Step 3. And Step 6. Survey design. Select the characteristics that are related to survey design. The tool has a data quality check module which has 4 subsections to guide the users. All figures in this module can be downloaded for further analysis. The 4 sections are: missing data, that is, any record of missing values. It is important to note that the original variables should always be retained, since their presence in the file guarantees data reproducibility and transparency. It is important that all records, including those with missing all measurements or sampling weights, are available for analysis, since they are important for data quality assessment. Input data distributions. Consider input data by users without adjustment or removal of implausible values. This feature is helpful for users to see the raw distribution of the data and to flag outliers. Outdated data distributions are the input data distributions considered after adjustments and removal of implausible values. This module also provides histograms to observe the frequency distribution and a table to observe normality measurements. Implausible values. The tool considers implausible values for hemoglobin and ferritin. Implausible values are considered as missing after required adjustments. In the results module, we can obtain the individual classification file and prevalence file. The individual classification file provides information on how each individual value on the global dataset was classified according to WHO recommended cutoffs. Users can download the results on CSV or Excel file. The tool allows to download prevalence data in 2 formats. The first format is the short format. This includes prevalence estimates using WHO recommended cutoffs with corresponding standard errors and confidence intervals and summary statistics. The second format is the long format, which includes prevalence estimates of a wide range of cutoffs with corresponding standard errors and confidence intervals and summary statistics. The tool also provides a data quality report This data quality report provides a consolidated analysis summary for the chosen biomarkers, including all data and figures generated by the tool. Now, let's work with a sample dataset using the training version of the tool that allows us to analyze hemoglobin. The first stage is the data file preparation. We should ensure that the data file contains variables in the accepted or recommended formats according to the Urrutia Micronutrient Analyzer quick guide. After ensuring the dataset is on the correct format, kindly save the data file in the comma-delimited format and begin the setup. We will work with the file shown on the presentation. Do not forget that for information on how to prepare the file, you can look at the quick guide. Please type the link that appears on the presentation. The web page should appear as presented here. Step 1. Upload the file. Please upload the CSV file. The tool will prompt the user when the data upload is complete. Step 2. Data preview. It allows the user to look at the uploaded dataset and to verify that the data uploaded looks okay. Step 3. Choose biomarkers. Open the drop-down arrow to choose the desired biomarker. For this time, we will choose only hemoglobin. Step 4. Map standard variables. In this step, we will select the input variables to map for age, sex, and pregnancy status if applicable. This is an example for step 4, map standard variables age mapping. Age can be mapped as computing age using date of birth and date of measurement, and just having the age variable. The recommended approach for calculating age is based on date of birth and date of measurement. If the radio button compute age using date of birth and date of measurement is selected, choose the variables from the drop-down menu if they are available in the dataset. For example, in the dataset, these are called DOB and DOM. If selecting the age variable only, please select the radio button and the appropriate variable from the drop-down menu for each column and each unit should be selected. For step 4, map standard variables, sex mapping, you should choose the sex variable as appears on your dataset from the drop-down menu. If applicable, step 4, map standard variables, pregnancy status mapping. In this example, we have a variable for pregnancy status and pregnancy weeks. Please note that when pregnancy status is unknown, it will be categorized as non-pregnant. Step 5. Biomarker-specific settings. Open the drop-down arrow for Step 5, Biomarker-specific settings. The markers ticked in Step 3 will be shown in blue for more detailed inputs. Click on the blue biomarker label. For hemoglobin, the tool requires hemoglobin concentration values and unit in gram over liter or gram over deciliter, and elevation in meters or feet. For analytical method attributes, please select the method of analysis, biological sample collected, and biological sample matrix. If data is available, kindly select the smoking status and number of cigarettes per day. Time of taking the sample, fasting, and malaria are optional for this biomarker. Step 6. Survey design, where strata and cluster, sampling weight, stratification, and disaggregation can be mapped to account for survey design and analyze population subgroups, strata and clusters. The purpose of stratification is to ensure that the sample is representative of the population of interest and divides the population into homogeneous groups, typically geographical groups, before sampling. Stratification in the sample design helps to reduce sampling errors when introduced at the initial stage of the sample. Sampling weight. A sampling statistician should create the sample weight. A sampling weight must be assigned to everyone in the sample to compensate for unequal probabilities of case selection if a sample, usually owing to the design in a cell-weighted sample, the weight is same for the individual and is usually equal to 1 for simplicity. To derive macronutrient indicator estimates, appropriate sample weights should be applied in each survey, while taking into consideration sample stratification. This is done to make sure that the sample population is fully representative. Stratify analysis for population subgroups when available. The most common population disaggregator factors are age, sex, type of residence, and regions or districts. For age grouping, standard analysis relies on the exact age in days, where available, to define age groups in months or years. Monitoring equity is of increasing importance for health and development. Disaggregated analysis is also recommended to derive estimates while well quintile and mother's education whenever this is possible. Once all required variables have been imputed, click on the green button Start Analyzer to run the analysis. The first feature that will appear after clicking the Start Analyzer button is the data quality check. Missing data. This module will show the percentage of missing values in a dataset. Missing data can be stratified by different variables to understand better the type of missing data and where improvements can be made in the survey design for collection phases. In this hemoglobin example, the figure shows the percentage of individuals missing information on variables used in the analysis. Missing data can be stratified by age, it can also be stratified by sex, and it can be also stratified by resident area, such as urban or rural. The second feature of the data quality check is the input data distribution, which considers input data without adjustment or removal of implausible values. This feature is helpful for users to see the raw distribution of the data and to flag outliers. All figures can be downloaded for further analysis. This is an example on how data is distributed in example dataset by age. Below, the example on how the data is distributed by age, but also by sex. This section also shows the distribution of the biomarker, in this case hemoglobin, and it can also be stratified by sex, by age, and other stratification. Here you can see the hemoglobin distribution stratified by sex, the hemoglobin distribution stratified by age, to enhance the visualization of the distribution of inputted and adjusted data. The tool allows the user to select a minimum and a maximum value for the x-axis to observe a wider or narrower distribution or skewness and kurtosis. In addition, due to abnormal distribution of more macronutrient biomarkers status data, the tool allows the selection of number of bars to closely observe the frequency of the data. In this example, the x-axis minimum value has been set to 0 and the maximum value set to 500, and the number of bars to depict the histogram is set to 300 bars. Another feature of the data quality check are the adjusted data distributions, which consider the data after adjustments, for example, elevation, smoking, inflammation, and it also removes implausible values. The tool provides a histogram of the adjusted data distribution for hemoglobin. The histogram is accompanied by a summary table with stratified characteristics of the biomarker. The tool considers implausible values as missing after required adjustments. A data table accompanies the graph. As commented in the previous slide, implausible values are considered as missing after required adjustments. The tool shows a graphic of the proportion of implausible values and an accompanying summary table. User can access to the results even before assessing the data quality of the data. However, assessing data quality can provide a better understanding and interpretation of results. The individual classification file provides information on how each individual value of the loaded dataset was classified according to WHO recommended cutoffs. Users can download the individual classification file as CSV or Excel file. The tool allows users to download prevalence data in two formats. Short format includes prevalence estimates using WHO recommended cutoffs with corresponding standard errors and confidence intervals, and summary statistics. Long format includes prevalence estimates of a wide range of cutoffs with corresponding standard errors and confidence intervals and summary statistics. Prevalence file, long format. The data file contains tabs for the selected biomarkers with unadjusted and adjusted values, for example, for ferritin and iron deficiency anemia, and a data dictionary for the long and short format. As we have selected only hemoglobin, we will only see a tab for anemia and a data dictionary. Here you can see the example for the prevalence file, short format. The last section of the tool is the data quality report, which provides a consolidated summary for the chosen biomarkers, including all figures and data tables generated by the tool. This is an example of the data quality report, where you can see the different figures and tables generated in previous sections. Finally, do not forget that for further guidance and details on how to use the tool, please refer to the WHO Micronutrient Survey Analyzer quick guide. We hope this tool can be useful for you when assessing micronutrient status of populations. Thank you very much for your attention. For more information, you can contact me directly or to our generic nutrition and food safety data email.